Elon Musk's companies, particularly SpaceX, and possibly his new aerospace venture, may or may not focus on developing sixth-generation fighter jets over national security considerations and ethical concerns. Elon Musk is making bold moves into aerospace with a sixth-generation fighter jet concept that aims to transform aerial combat using cutting-edge technology and capabilities that seem almost unreal. Could this groundbreaking innovation make current military strategies outdated? And what hidden aspects define the design and functionality of an aircraft that might revolutionize modern warfare? Stay with us as we explore Elon Musk's unveiling of a sixth-generation fighter jet that challenges all known physics. Elon Musk has not been actively involved in designing or manufacturing traditional fighter jets, nor has he introduced a military aviation project aimed at building conventional fighter aircraft. His influence in aerospace within military discussions arises from his visionary perspectives on the future of air combat and his deep involvement in space and rocket technologies through SpaceX. Musk's statements about fighter jets gained widespread attention in 2020 when he declared at the Air Warfare Symposium that the era of manned fighter jets was coming to an end. He predicted that the future of aerial combat would likely be dominated by AI-powered autonomous drones, capable of surpassing and outmaneuvering traditional fighter jets. His remarks piqued interest within the U.S. Air Force, increasing enthusiasm for unmanned aerial systems to serve as both partners and potential replacements for conventional fighter jets in specific missions. Musk has strongly advocated for the evolution of fighter jet technology to incorporate unmanned systems that can either fly independently or operate as wingmen to human pilots. He suggested creating highly competitive AI-powered drones that could rival advanced fighter jets like the F-35. To Musk, such an approach would push the limits of speed, maneuverability, and rapid decision-making in ways that manned jets, limited by human capabilities, could never achieve. He further elaborated on social media that a drone equipped with advanced maneuvering autonomy could easily surpass a piloted jet like the F-35, effectively making it obsolete in various combat scenarios. His viewpoint highlights Musk's broader belief in AI's ability to enhance decision-making and responsiveness in critical situations, an ideology that has also shaped his work at Tesla and SpaceX. Musk's primary contributions to aerospace come through SpaceX, where he has transformed rocket technology with advancements such as reusable launch vehicles, significantly lowering the cost of space missions. These breakthroughs have made him a crucial partner to NASA and other government and military agencies focused on space, strengthening the nation's security capabilities beyond Earth's atmosphere. SpaceX has initiated projects like Starlink, a satellite-based internet service that holds potential military applications. From providing global communication access in remote and conflict-stricken regions to enhancing space-based defense systems, this has positioned Musk at the center of discussions on space defense strategies, even though he is not directly involved in manufacturing fighter jets. Musk's insights have sparked important debates within the U.S. military, particularly in relation to the Next Generation Air Dominance (NGAD) program, which envisions a future where AI and autonomous drones could handle combat missions. While he does not produce fighter jets, his perspectives on defense and technological advancements emphasize the strategic role AI and autonomy might play in future warfare. His influence has led military leaders to consider adopting high-tech, AI-driven air superiority systems for the coming decades. Musk's work in aerospace, primarily through SpaceX, has influenced military aviation by advancing reusable rocket technology, satellite networks, and broader defense strategies. Reusable rockets, such as the Falcon 9 and Falcon Heavy, have significantly reduced the cost and frequency of satellite launches, giving the military greater access to space-based capabilities. These satellite launches are used by the U.S. military for critical space missions, including secure communications, GPS navigation, and reconnaissance, key elements in modern air, land, and naval operations. The rapid deployment of these space assets strengthens national security by ensuring a reliable orbital defense infrastructure. Another major contribution is SpaceX's Starlink, a global satellite internet network designed to provide high-speed internet even in the most isolated regions. Starlink has demonstrated its military potential by offering secure and resilient communication networks in conflict zones, in remote areas where traditional communication systems may be compromised. This technology has already been tested for such purposes, proving its value for deployed military personnel who require stable and secure communication channels in challenging environments. Musk's perspective on the future of military aviation has also shaped U.S. military strategies. He has repeatedly stated that autonomous drones could outperform human-piloted fighter jets in combat. He envisions a future where AI-powered drones achieve unmatched maneuverability and speed that human-controlled aircraft simply cannot match. This viewpoint has contributed to discussions within the U.S. military, particularly regarding the NGAD program, which aims to integrate autonomous drones as wingmen alongside piloted fighter jets. Musk's emphasis on AI-driven warfare aligns with an Air Force increasingly interested in using drones for complex missions, potentially replacing traditional manned aircraft in specific roles. SpaceX has become a key player in launching and operating space-based defense assets for the U.S. Space Command. These assets serve national defense purposes, playing crucial roles in surveillance and early warning systems that extend military situational awareness into space. SpaceX's contributions help enhance the military's ability to detect and respond to emerging threats, reinforcing defense capabilities for the U.S. and preparing military forces for the evolving challenges of space-based warfare, alongside traditional air and land operations. As for sixth-generation fighter jets, these aircraft incorporate a variety of advanced technologies designed to surpass the capabilities of current fifth-generation jets, like the F-35 and F-22. One key feature is enhanced stealth and survivability. While fifth-generation fighters already prioritize low radar visibility, sixth-generation jets will push stealth even further, using advanced materials and thermal management techniques to minimize radar and infrared detection. AI and autonomous systems will also play a vital role in sixth-generation fighters, enabling capabilities beyond traditional piloted operations. These aircraft will integrate AI for autonomous decision-making, allowing them to analyze threats and coordinate with unmanned wingman drones. This setup will enable pilots to focus on broader strategic objectives, while AI handles real-time tactical adjustments. Sensor fusion and battlefield connectivity will be another defining characteristic of sixth-generation jets. These aircraft will function as networked nodes, sharing real-time data with other jets, drones, and ground systems to create a more comprehensive view of the battlefield. Additionally, directed energy weapons such as laser systems are expected to be integrated, offering advanced defensive measures against incoming threats, potentially providing an unlimited supply of ammunition compared to conventional munitions. Other features include long-range operational capabilities, high-speed agility, and adaptive engines for sustained supersonic flight, making sixth-generation jets superior in rapid response and deployment. Several countries are actively developing sixth-generation fighter jets. The U.S. leads with its NGAD program, aiming to introduce advanced manned fighters paired with AI-driven wingman drones by the 2030s. The United Kingdom, Japan, and Italy are collaborating on the Tempest Fighter project, which is expected to incorporate AI-driven decision-making and advanced networking capabilities by the mid-2030s. France, Germany, and Spain are working on the Future Combat Air System, FCAS, while China and Russia are also developing their own advanced fighter jet programs, emphasizing AI, hypersonic weapons, and stealth technology. Despite their advantages, sixth-generation jets face several challenges, including high costs, technological complexities, and ethical concerns. The financial burden of developing these aircraft is immense, and maintaining AI-powered systems presents security risks, including potential cyber threats and decision-making failures. The ethical implications of AI autonomy in lethal military operations further complicate their deployment. While Elon Musk's companies are not directly manufacturing fighter jets, his views on AI and autonomous drones continue to influence military aviation, reinforcing the shift towards AI-driven aerial combat and the future of warfare.